Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Fahim bin Abdul Razak, and my student ID is 2019278428, and my group is J4EE12122B1. Okay, today I want to present my assignment for subject EE11 EE121, which is circuit subject. Okay, I have two question to do, which is question 1 and question 2. Okay, for the question 1, there is a superposition theorem to do in that question. Superposition theorem, which is state that in any linear active bilateral network having more than one source, the response across any element is the sum of the responses obtained from each source considered separately, and all other sources are replaced by their internal resistance. The superposition theorem is used to solve the network where two or more sources are present and connected. Other than that, on that first question, I use the CDR, which is current divider rule. Current divider rule have two or more parallel branches for currents to flow through, but the voltage is the same for all components in the parallel circuit. Other than that, I also use the VDR, which is voltage divider rule. Voltage divider rule is used to solve circuits to simplify the solution. Applying this rule can also solve simple circuits thoroughly. The main concept of this voltage divider rule is the voltage is divided between two resistors which are connected in series in direct proportion to their resistance. Voltage divider rule involves of two important parts, the circuit and the equation. And lastly, for the question 11, I use two steps, which is Kirchhoff law. Kirchhoff law are divided by two, which is Kirchhoff current law and the Kirchhoff voltage law. For the question 11, I use the Kirchhoff current law and the current divider rule to solve the problem. Kirchhoff current law, the three currents entering the knot, which is I1, I2 and I3 are all positive in value, and the two currents leaving the knot, I4 and I5, are negative in value. Then this means we can also rewrite the equation as 1I1 plus I2 plus I3 minus I4 minus I5 equal to 0. And the CDR is that I've explained before this. Okay, let's go for the question 1. Okay, let's go for the question 1. Compute the I0 in the circuit. This is the circuit based from the question. So I draw the first step circuit. Okay, at this part they have a voltage which is 50 voltage, and I didn't draw because this part we should to ignore that. By ignoring 20 ohm, current will flow in short circuit. So the current and then I draw the second step, which is I ignore the 20 ohm resistor and the 50 voltage source. So the circuit will be in short circuit. So like this, we have a 20 ohm resistor, 15 ohm, 10 ohm, and then 10 ampere for the current source. Okay, and then using CDR to find 15 ohm. So we should to find the first I0. So the the step is, the equation is I naught 1 equal to 20 over 20 plus 15 multiplied by 10 ampere. So we will get the 5.7 ampere for the first I naught. And then for the third diagram, I ignore the right part, which is we have 10 ampere before this and 10 ohm. So I didn't draw it because I want to ignore it. And look at this, we draw the 50 volt source. Voltage at 20 ohm is 50 volt because of the voltage is same when parallel. So at this part I combine, because 20 ohm and 50 voltage when in parallel the value of voltage is the same. So I draw the circuit like this. So this means that I simplify the circuit using VDR at 15 voltage equal to 15 over 20 plus 15 multiplied by 50. So we will get 21.4 volt. At the next step, I using the Ohm's law. The formula is V equal to IR. So I just put the voltage 21.4. So 21.4 equal to I multiply by 15, which is R equal to 15. This. So I calculate that 21.4 over 15, and we will get 1.43 ampere. This is for the I, not for the second. And lastly, find I naught. I naught equal to I naught 1 plus I naught 2. We will get 5.7 ampere plus 1.43 ampere equal to 7.13 ampere. To get this and this, just sum from this and this. End of question 1. Okay, and then we go for the question 11. By applying Kirchhoff law and current divider rule to the circuit shown in figure, question 11, find the current value of Ix, Iy and Iz, the power absorbed by 28 ohm resistor. For the first step, I draw the diagram same like the question, and I state every single part in the circuit. So the important thing which is we should to find the Ix, Iy and Iz and the power absorbed by 28 ohm. Okay, for the first step this, and the second step this, I switch or I transfer, I change this resistor, this part become the delta, which is star from delta. I change the resistor from star to delta, and this is the step to change star to delta. The formula is Ra equal to R1 multiply R2 plus R2 multiply R3 plus R3 multiply R1 over R1. So I use this formula to get Ra, Rb and Rc. The formula, the value that I get is from Ra is 75 ohm, Rb is 34.09 ohm and RC is 18.75 ohm. And then I just sum 12 ohm plus 28 ohm, and then I will get 40 ohm. This step I use from this is the series, so I sum this. Okay, let's go. For the third step, this is the drawing. After that sum, this is the series that I have sum from before this, and then I just do the parallel this to this with this 1/40 plus 1/75, and then I get 26.09 ohm from this parallel. So I rearrange the circuit to become like this. Why I ignore this one, which is 34.09 ohm? Because of current is only flow through the plain wire, so I just ignore this part. And then for the next step, I calculate the parallel from this value and this value, which is 1/18.75 plus 1/26.09. We will get 0.91 ohm. From this 0.191 ohm, I just sum from 2 ohm with the value that I have calculated, which is 2 ohm plus 0.91 ohm. We will get 12.91 ohm. And then I use the V equal to IR, which is 36 equal to I multiply 12.91 ohm. So the I total we will get 2.79 based from this calculation. For the next step, we back to the first picture. So after we calculate the I total, so I28, which is I want to find this IX, it flow from at 28 ohm, so I28 equal to 75 ohm over 40 plus 75 ohm, multiply 2.79 ampere, so we will get 1.82 ampere. That means that Ix equal to 1.82 ampere. I want to find this Iy, so I use this formula, I total equal to Ix plus Iy. So I will get Iy equal to 2.79 ampere minus by 1.82 ampere, and I will get 0.97 ampere. So that means that Iy equal to 0.97. And for the Iz, I use this formula, 5 Iz in the bracket Iz minus It plus 20 bracket Iz minus Ix equal to 0, and I just multiply, and I multiply in the bracket, the value in the bracket, and then I rearrange that. So I will get 25 Iz equal to 50.35. So Iz equal to 50.35 minus 25, and then I get Iz equal to 2.01 ampere. So I solve this. I get X, Iy, and Iz, and then lastly power absorbed by 28 ohm. I use to find this, I use the power formula, and then for the current I use 1.82 because you want this question want 28 ohm. So I 1.82 bracket power of 2 multiplied by 28. So I get 92.75. That's all from me. Thank you.